far away. In the deep past, the shape of the continents is not what it is today. Ice lies heavy across the northern hemisphere. Glaciers stretch far south into Europe, Asia, and North America. The oceans are locked in frozen sheets, and the seas are lower by more than 100 meters. Where water once covered the shallows, land emerges. Wide plains extend far beyond the present coasts. Rivers cut through exposed valleys. Shorelines reach far out to what we now see as the deep ocean. It is along these ancient coasts that early humans walk. They move slowly, step by step, over sand and stone. They follow the edges of continents, where food is easier to find. The tide uncovers shellfish. Driftwood gathers in estuaries. Birds settle on the sand to nest. For hunter-gatherers, the coast is a place of abundance. At the same time, it is also a place of risk. Storms rise suddenly. Tides change quickly. Yet people linger here because the resources are rich. Archaeological traces tell us that coasts were among the earliest corridors of movement. A single piece of obsidian found far from its volcanic source speaks of journeys taken along the shore. A shell bead, polished and pierced, lies buried more than 100 kilometers from the sea. These are fragments of forgotten lives. They show how people carried objects, traded them, or perhaps simply lost them while walking. The global climate, shaped by ice age cycles, explains much of this expansion. As glaciers advance, sea levels fall, opening new routes. As glaciers retreat, seas rise again, closing them. This rhythm of exposure and flooding repeats many times over tens of thousands of years. Whole landscapes appear and vanish. An open plain one century becomes a drowned shelf the next. To live in such a world is to adapt constantly. Humans learn to read shifting coasts, to move as water dictates, to take what is offered, and to retreat when the ocean demands. Along the shores of East Africa, groups of Homo sapiens gather. They have lived here for many generations. The beach offers crabs, clams, and fish trapped in tidal pools. The nearby forests give firewood and fruits. From these bases, some begin to wander further, pressing into Arabia and beyond. The coastlines become stepping stones out of Africa. Elsewhere, different humans also use the sea. Neanderthals in southern Europe collect shells and pigments. On the island of Crete, evidence hints at visits tens of thousands of years before farming. Even earlier, on Flores in Indonesia, stone tools speak of a presence more than 1 million years ago. These scattered records suggest that the idea of reaching new lands across water is not limited to one species. It is a shared pattern, though fragile and rare. Still, one mystery remains: how intentional were these early movements? Did people build rafts and push out deliberately, knowing land waited beyond? Or were they caught by storm and carried by currents and stranded on distant shores by accident? Archaeologists debate this question. No boats survive from such ancient times. Only indirect signs, stone tools, bones, charcoal remain to be read. Some scholars argue for skill, for knowledge passed down across generations. Others say the crossings were chance, repeated enough times that a few succeeded. Whatever the case, the coastlines are central. They frame human choices. They shape where groups can live and where they must leave. They are the thresholds of worlds between land and sea, safety and uncertainty, known and unknown. Far to the east, In what is now Southeast Asia, vast tracts of land lie exposed. Sunda, the great shelf linking many islands, stretches from modern Thailand to Java. It is a continent of its own, covered in forests and rivers. People walk freely across these plains. Beyond, however, lies another barrier, the Wallace Line, a deep channel where sea never retreats. To cross it requires water travel. Beyond it lies Sahul, the ancient continent of Australia and New Guinea.
To reach it, humans must take to the sea.
Before they do, life on the coasts trains them. They learn to use fire on beaches where wind clears smoke. They gather shellfish in baskets woven from reeds. They shape stones into blades sharp enough to cut sinew and wood. Some scatter pigments on rock faces above the tide. These practices show adaptability, resilience, and the beginnings of symbolic thought. Planetary forces continue to reshape the scene. The tilt of Earth changes, ice sheets grow, then melt. Ocean currents shift. Winds alter course. With each shift, human groups respond. They migrate along shorelines that stretch like endless roads. They camp where rivers meet the sea. They watch the moon to read the tides. They listen to the sound of waves crashing against new land. In doing so, they slowly prepare for greater journeys. One small campfire, built at the edge of an estuary, leaves behind blackened soil. Thousands of years later, archaeologists sift the ash and find burned fish bones. Another site preserves footprints hardened in mud. They show the path of adults and children walking together along a lagoon. Each print is a reminder that these places were lived in, however briefly. The challenge for science is that most of these coasts are now gone. As the Ice Age ends and seas rise, the ancient beaches are drowned. Entire landscapes vanish underwater. Archaeologists must rely on rare exposures, eroded cliffs, uplifted terraces, caves that once opened to the sea. The vast majority of human coastal life remains hidden beneath the waves. This silence of evidence is itself a mystery. We know the importance of coasts. We see hints in scattered finds, yet the full story is drowned. To reconstruct it requires not only archaeology, but also geology, oceanography, and genetics. Studies of DNA reveal patterns that suggest small founding groups moving along these lost shorelines. Their descendants still carry the echoes of those migrations. The story of early humans on coasts is one of adaptation to a changing planet. Shorelines expand, then retreat. Islands appear, then vanish. Food supplies rise and fall. Yet humans persist. They walk, they gather, they cross. In this persistence lies the foundation of all later voyages. Without it, the leap to remote islands would never have been possible. The ancient shorelines are therefore both stage and teacher. They show how fragile life can be, poised between land and sea. They also show how enduring human survival is, shaped by patience, observation, and movement. Even as glaciers grind continents and seas rise to erase entire worlds, small groups of people leave behind traces. They are footprints, tools, shells, and ashes. Together they whisper that humans have always lived with the edge of the ocean, and always will. On the wide coasts of Southeast Asia, the sea stretches out like a barrier. The horizon looks endless, yet scattered islands break the distance. Some are only a few kilometers away, others lie just beyond sight, hidden by haze and waves. For early humans, these islands are both opportunity and challenge. They promise new resources, but they demand a crossing that is uncertain. The remains of driftwood along ancient beaches hint at one solution. Logs wash ashore after storms, carried by swollen rivers or typhoon winds. Some are thick enough to bear weight, floating low but steady. People may have seen how branches, tangled together, held buoyant on water. They may have tried to ride them, first in play, then with purpose. A fallen trunk becomes a raft, even without shaping. Archaeologists searching these regions find stone tools on islands that were never joined to the mainland, even at the lowest seas. Flores is one such place. To reach it required a water crossing of at least 20 kilometers. Yet tools there are more than 1 million years old, long before Homo sapiens. This fact suggests that earlier human, perhaps Homo erectus, managed to drift or paddle across. Whether by accident or design remains unknown. Still, the evidence shows that even without advanced boats, some form of crossing was achieved. In calmer waters, bamboo may have served. When cut, it traps air in sealed chambers, floating high, bundled together. Bamboo poles form a surface stable enough to sit on. Reeds, too, can be tied into rafts. Such materials are abundant along tropical rivers. Fire-hardened stakes could push against shallow bottoms, moving a raft across lagoons or narrow straits. None of these constructions survive in the archaeological record. Yet ethnographic parallel, combined with logic, make them plausible. The risk of the sea cannot be ignored. Currents in these regions are strong, driven by monsoon winds. A raft set adrift can be carried far from sight of land. Storms rise suddenly, overturning small craft. Many who attempted to cross likely perished. Yet the persistence of humans means that some succeeded. Over generations, the knowledge of how to balance, how to steer, how to choose the right season may have grown, step by step. These practices become tradition. Evidence from obsidian tools supports the idea of early seafaring skill. In the Bismarck archipelago, pieces of volcanic glass are found far from their source. The distances involved exceed 100 kilometers. Such transport suggests repeated crossing, not a single chance event. It implies networks of exchange, maintained by people who knew how to move across water with intent. Still, one mystery lingers. Did early humans set out looking for new land, or did they only see it once they were already adrift? In some cases, islands are visible from the coast on clear days. Smoke from fires, or the flight of birds, might mark them. In other cases, no land is in sight. Crossing to Sahul, for example, required several stages, with water always in between. Scholars debate whether people understood what lay ahead. Some argue that star patterns, wind directions, and bird movements gave clues. Others suggest trial and error, with generations repeating journeys until the route became known. On a planetary scale, the lowering of seas during glacial periods makes such crossings easier. Distances shrink. Islands that are now separated by wide channels once lay closer together. A voyage that today demands advanced boats may then have required only a short paddle. And this does not diminish the achievement. It shows instead how closely human expansion ties to climate. When Earth freezes, oceans retreat, and possibilities open. When Earth warms, seas rise again, and those routes vanish. The coastlines become training grounds for these attempts. Children watch their elders push rafts into lagoons. They learn to hold balance on slippery logs. They see how fish can be caught from a floating platform. They notice how wind carries smoke across the water. Knowledge accumulates quietly, one observation at a time. Over centuries, these fragments add up to skill. Archaeological finds also reveal the role of fire. Charcoal layers on island sites show that people carried embers with them. A raft or canoe may have held a clay-lined pit to keep fire alive. Without fire, survival on new islands would have been harder. It provides warmth, protection, and the ability to cook shellfish or roots. That such traces exist suggests planning. People did not arrive empty-handed. They brought the essentials of life with them. On Flores, the presence of Homo floresiensis adds another layer of enigma. These small-bodied humans may themselves have been the descendants of earlier seafarers. Their very existence shows that isolation could shape evolution, reducing size, changing form. If they arrived by accident, the accident must have been repeated or sustained for a population to endure. If they arrived deliberately, then their skill must have been greater than once believed. Either way, the island stands as proof that water crossings happened deep in time. Genetic studies of modern populations in Oceania hint at these early stages. The lineages trace back tens of thousands of years to small groups who once dared to leave the coast. Their descendants still carry signals of those first crossings. Each strand of DNA is like a raft itself, carrying memory across generations. The global view shows how rare, yet transformative, these steps were. Not all humans became island settlers. Many stayed on continental plains, never seeing the open ocean. But those who did cross began a process that would spread people to the farthest reaches of Earth. The Pacific, the Indian Ocean, even the Americas, all would one day be reached by sea. The first uncertain rafts were the beginning of this long story. A fragment of shell, polished by hands, may once have been worn as an ornament during such a voyage. A stone flake, sharper than bone, may have been carried in a pouch. These objects, found today on remote islands, are faint echoes of those journeys. They speak of lives risked and sustained. They remind us that survival was never simple, yet always possible. Standing on a glacial shoreline, watching waves crash, early humans faced choices. Stay on the familiar coast or step onto a raft and drift toward the unknown. Some chose to risk it. Their footprints vanished long ago, but the islands they reached still hold their presence. In the silence of forests, in the layers of caves, in the scattered stones of ancient camps, their passage is remembered. The vast continent of Sahul waits across the deep channels of sea. In the Ice Age world, Sahul is not two islands, but one great landmass. Australia, New Guinea, and Tasmania are joined together by plains exposed in lowered seas. To reach it from Sunda, the Asian shelf, humans must cross stretches of open water. These are not small lagoons or narrow straits. At their shortest, the crossings measure more than 60 kilometers. Some stages require land never visible from the departure shore. It is one of the earliest great challenges faced by Homo sapiens. Archaeological dates now show that people arrived here more than 60,000 years ago, perhaps even earlier. Charcoal layers, stone tools, and butchered animal bones from Majidbebe in northern Australia push the timeline back. In New Guinea, similar evidence confirms early occupation. These finds prove that small groups of humans did not only attempt the voyage, they succeeded, and they established lasting communities. One striking detail comes from genetic studies. The ancestors of indigenous Australians and Papuans split from other human populations soon after leaving Africa. Their lineages are among the oldest continuous on Earth. This means that the crossing to Sahul was not a late event, but an early one, part of the first waves moving eastward. The journey defined the destiny of an entire branch of humanity. What did those first arrivals see? The coasts of Sahul were unlike anything known before. Marsupial animals dominated, creatures with pouches instead of placentas, giant kangaroos, towering 2 meters, grazed on open plains. Wombats the size of small cars moved slowly across the grasslands. Enormous, flightless birds, heavier than ostriches, nested on sandy ridges. For humans stepping onto these shores, every plant and animal was unfamiliar. The challenge of survival required learning everything anew. Stone tools tell part of the story. On ancient dunes and riverbanks, archaeologists recover flakes and cores. They show that people adapted quickly, finding new raw materials, shaping them into blades and scrapers. The presence of grindstones suggests processing of seeds, perhaps from grasses unique to Sahul. These tools reveal innovation, but also continuity. Techniques carried from Sunda were adjusted, not abandoned. Tradition guided the first steps, even in strange lands. Among the most compelling signs of settlement are the remains of cooking fires. At Lake Mungo, in Australia, blackened hearths lie buried beneath sand. They date back more than 40,000 years. Around them, fish bones and shells suggest meals shared at the water's edge. Here, people adapted inland as well as coastal. They followed rivers and lakes, spreading across deserts and mountains. The pattern of dispersal shows flexibility, resilience, and determination. A lesser-known detail is the discovery of ochre at many sites. This iron-rich pigment, red or yellow, was ground and used for colouring. At Arnhem Land, fragments of painted rock remain. These are among the oldest symbolic expressions in the world. They show that the people who crossed to Sahul carried not only tools, but also ideas. Symbolism, ritual, and art were part of their survival. In unfamiliar landscapes, meaning was as essential as food.
Yet mysteries remain. How exactly do they manage the voyage? No boats survived from 60,000 years ago. We can only speculate. Some archaeologists suggest bamboo rafts or canoes made from bark. Others point to logs lashed together with vine. Whatever the form, the construction had to be strong enough for families, supplies, and fire. The success of settlement implies skill beyond accident. Repeated journeys, carrying enough people to form viable groups would not happen by chance alone.
On the planetary scale, this migration reflects the interplay of sea and climate. During glacial periods, when ice locked away water, the distances were shorter, but they were never absent. The Wallace Line remained, a deep barrier that currents could not erase. To cross it required intentional movement. This marks one of the earliest examples of humans conquering a natural frontier through technology and planning. It is a moment when human ingenuity and the forces of Earth met directly. In Sahul, evidence of megafaunal extinction soon follows human arrival. Many of the largest animals vanish within a few thousand years. Some scientists argue that hunting pressure drove them to extinction. Others blame climatic shifts, as rainfall patterns changed and habitats contracted. The debate continues. What is clear is that human presence coincided with ecological transformation. Survival on Sahul was not passive. It reshaped the land as people burned grasslands, hunted, and settled. Footprints in ancient mud tell us more. At Lake Mungo, dozens of tracks preserved in hardened clay record a group moving together. Adults and children walked side by side, some running, some pausing. These traces are fleeting moments turned to stone. They remind us that the first Australians were not only survivors, but communities. Their journeys were collective, bound by kinship and continuity. A detail often overlooked is that these early settlers did not stop at the coast. Within a few millennia, they reached the highlands of New Guinea and the deserts of Central Australia. This rapid spread shows remarkable adaptability. From tropical forests to arid plains, they thrived. Each environment demanded different strategies: hunting, gathering, fire management, water storage. The knowledge passed down ensured survival in extremes. The genetic legacy still endures. Studies show that Indigenous Australians and Papuans carry traces of Denisovan ancestry, a mysterious cousin species. This suggests encounters somewhere along the journey, perhaps in island Southeast Asia. The fact that these genes remain today links living people to a deep and complex past. It also highlights how migration was never a simple line, but a web of crossings, meetings, and exchanges. One unresolved question is whether the first arrivals to Sahul came in a single wave or multiple. Some scholars argue for a rapid colonization, a single, bold push. Others see evidence for repeated crossings, bringing different groups at different times. Archaeological sites are patchy, and rising seas have erased many. The debate is far from settled. Each new discovery adds another piece, but the full pattern remains hidden. From a wider perspective, the crossing to Sahul marks a turning point in human history. It shows that our species could leave continents, cross oceans, and establish life in wholly new worlds. It foreshadows the later peopling of the Pacific and the Americas. It proves that even with simple tools, humans possessed vision, skill, and persistence. Standing on the northern shores of Sahul, looking back across the sea, those first settlers faced a horizon they would never return across. Behind them lay Sunda, the old world. Ahead stretched a continent of strange animals and uncharted lands. They had crossed into a new chapter of human existence, one that would continue unbroken for tens of thousands of years. When the first humans step onto Sahul, they enter a realm unlike any they have known before. The animals that greet them are not the great cats or elephants of Africa, nor the herds of deer and bison of Eurasia. Instead, they find marsupials of immense size, birds taller than men, and reptiles that seem to belong to an older age. This is a continent of giants, yet also a continent of strangeness. For survival, we humans must adapt quickly, learning to read behaviors and patterns that are entirely new. Among the most striking of these creatures are the diprotodons. These colossal wombat-like animals weigh over 2 tons and browse on low vegetation. Slow-moving, they might seem easy prey, but their sheer size and strength make them formidable. Close by, giant kangaroos graze in open grasslands. Some stand over 2 meters tall, their powerful legs capable of delivering dangerous kicks. To hunt such creatures requires more than bravery. It demands planning, cooperation, and new tools. Birds also dominate the landscape. The flightless Genyornis, heavier than an ostrich, lays large eggs in nests across sandy plains. Archaeological evidence suggests humans collected and cooked these eggs. Fragments of burned shell found in ancient hearths point to a diet supplemented by these rich resources. For a people new to this world, such food sources provided crucial energy. Yet the act of gathering them may also have carried consequences. With repeated harvesting, bird populations declined, and within a few thousand years, Genyornis disappears. Reptiles add another layer of challenge. Saltwater crocodiles, already ancient survivors, patrol rivers and coasts. On land, the giant lizard Megalania roams, a predator up to 5 meters long. Its bite may have carried venom, making it even more dangerous. For humans used to lions or wolves, these creatures are unfamiliar threats. To live among them requires vigilance. Camps must be placed carefully. Water must be approached with caution. Each decision holds weight between safety and risk. The ecological richness of Sahul is balanced by its fragility. Many of these large animals reproduce slowly. They cannot withstand heavy hunting. Climate shifts also strain their habitats. Humans, arriving with fire, stone blades, and organized hunting, alter the balance further. Over time, megafauna decline. Some vanish entirely. The debate continues among scientists. Was it hunting pressure, changing climate, or both that caused these extinctions? The answer may never be fully clear, but the timing of human arrival and animal disappearance is closely linked. For archaeologists, one key site is Cuddy Springs in New South Wales. Here, stone tools lie in layers alongside megafaunal bones. The association suggests direct interaction, perhaps even butchery. Another site, in the Willandra Lakes region, preserves hearths and animal remains together. These places capture the moment when humans and giants shared the same ground. They show that survival meant not only confronting strangeness, but also reshaping ecosystems. Less well known is the evidence of fire management. Charcoal deposits across Sahul indicate deliberate burning. People set small fires to clear undergrowth, encourage fresh shoots, and drive animals into the open. This practice, sometimes called fire stick farming, transforms landscapes. Grasslands spread, and certain plants flourish. For humans, it makes hunting easier and plant gathering more productive. For megafauna, however, it reduces habitats. Over time, these changes ripple through the entire environment. On a planetary scale, this moment reflects the growing influence of humans as ecological agents. Until now, survival had meant adapting to what nature offered. In Sahul, survival also means shaping the land. Fire, tools, and group action alter patterns of vegetation and animal movement. The balance between humans and their environment shifts. This is a subtle but significant turning point. Mysteries remain in the details. Did people hunt the largest animals directly, or did they focus mainly on eggs, smaller prey, and plant foods? Were extinctions rapid, within a few centuries, or gradual over thousands of years? The archaeological record is patchy, and rising seas have erased many coastal sites. Each discovery sparks new debates, reminding us that the story is incomplete. Still, what is clear is the adaptability of the first settlers. They arrive in a world of strangeness and survive. They learn which roots are edible, which animals can be tracked, which birds can be approached. They discover new materials for tools, new shelters for camps, new rhythms of season and migration. In time, they spread from northern coasts to inland deserts, from lush forests to arid plains. Survival is not passive endurance. It is active learning, constant observation, and flexible response. Ochre, found in many Sahul sites, offers another glimpse. Beyond its symbolic use, may have had practical purposes, tanning hides, protecting skin, or preserving wood. Its presence in early camps shows that people applied knowledge in creative ways. They were not only hunters and gatherers, but also experimenters, adjusting to every challenge the land presented. From a genetic perspective, the small founding populations carried only limited diversity, yet they endured for tens of millennia, creating rich cultural traditions. Rock art across Arnhem Land and New Guinea highlands testifies to symbolic life deeply embedded in survival. The art often depicts animals, some no longer present, suggesting memory preserved even after extinction. These images are both record and reflection, a bridge between the natural world and human understanding. One remarkable detail is that watercraft skill must have been maintained long after arrival. Rivers, lakes, and coastal routes required ongoing crossings. Even inland, rafts may have been used to transport goods or people. This means that the seafaring knowledge which brought humans to Sahul did not vanish. It became part of daily life, ensuring continuity between the old skills and new realities. Standing within this world, early humans lived at the boundary of abundance and risk. Every hunt carried danger. Every campfire attracted both community and predators. Yet through cooperation, innovation, and observation, they thrived. The footprints left in mud, the ashes buried in sand, the pigments smeared on rock, all are echoes of lives lived fully in landscapes unlike any before. On the scale of Earth, the settlement of Sahul shows the reach of human possibility. From Africa to Arabia, from Sunda to Australia, people had crossed deserts, rivers, and seas. Now they lived among creatures found nowhere else, shaping ecosystems with fire and choice. The story of life among giant marsupials is not just about survival. It is about the expanding horizon of what it meant to be human. Along the shores of Sahul and the islands that frame it, stone tools begin to tell the quiet story of human survival. Archaeologists uncover fragments of flaked rock, shaped by careful hands tens of thousands of years ago. These tools, small and plain at first sight, hold within them the strategies of adaptation. Each flake is a decision. Each edge is a memory of need, cutting meat, scraping bark, or carving wood. In the stillness of excavation sites, the stones speak of how humans endured at the edge of the sea. The coastlines of this ancient world provided both promise and challenge. Food was abundant in certain seasons, scarce in others. Shellfish could be gathered at low tide, but storms could strip beaches bare. Fish could be trapped in tidal pools, but only if people knew the rhythm of the moon and the tide. Tools became essential to make this abundance reliable. Sharp flakes cut open shells. Scrapers cleaned fish skins. Awls pierced holes in hides for carrying baskets. Without such instruments, the richness of the coast could not be fully used. At Lake Mungo, in southeastern Australia, archaeologists have found grindstones dating back more than 30,000 years. These stones were used to process plant foods, grinding seeds into meal. On coastal dunes, stone flakes lie beside shell middens, showing that gathering and preparation went hand in hand. The presence of these tools demonstrates foresight, gathering food in large amounts, then making it edible, then storing or sharing it. Survival along ocean edges was not just about finding food, but transforming it. A lesser-known detail emerges from obsidian artifacts in Melanesia. Obsidian does not occur everywhere. Its presence on distant islands shows that humans carried or traded it. Obsidian tools were valued for their razor-sharp edges, capable of slicing with precision. The fact that pieces traveled over water means that coastal communities were connected even across distances. Stone tools were not only instruments, they were links between groups. On a planetary scale, the role of stone technology reflects a pattern repeated everywhere humans lived. As climates shifted, as glaciers advanced and retreated, tools changed in form but not in importance. In the Arctic, blades cut hides for warm clothing. In deserts, scrapers shaped wood for digging sticks. In Sahel and its coasts, the same logic applied. Tools were the flexible thread binding survival to place. Wherever humans walked, they carried stones shaped by memory and skill. The mysteries remain in the details of manufacture. Many tools are simple flakes, struck from cores with little modification. Were these meant as temporary implements, used once and discarded, or were they part of a broader toolkit, carried from site to site? Some archaeologists suggest that mobility itself shaped tool design. Light, versatile tools suited groups always moving. Others believe that more complex tool, lost to time, once existed in wood or fiber. Without preservation, the stone alone survives, leaving questions unanswered. Yet even these simple stones reveal much about knowledge. The angles of flake scars show that makers understood force. The choice of raw material, fine-grained chert, volcanic glass, quartz, shows selection and judgment. In places where good stone was rare, people transported it. This implies planning, even anticipation of future needs. A stone struck far inland might later serve to butcher fish on a distant shore. The link between land and sea, between forest and coast, is written in these objects. Another puzzle lies in the absence of certain tool types. Bifaces, common in Africa and Europe, are rare in Sahel. Instead, unifacial flakes dominate. Was this due to different traditions carried from Sunda? Or was it shaped by the availability of materials? The answer is debated. What seems clear is that local conditions mattered. Humans arriving on new coasts adapted their traditions to what the land offered. The continuity of survival did not require uniformity of form. Along the beaches, people also used shell itself as tool. Cut marks on shell fragments suggest scraping and engraving. Some shells were pierced, perhaps worn as ornaments. Others were sharpened for cutting. These improvisations highlight human flexibility. If stone was scarce, the sea provided substitutes. The boundary between tool and ornament blurs in these contexts. Utility and meaning are interwoven, as they so often are in human history. In caves near coastal cliffs, archaeologists find hearths blackened with soot. Mixed within the ash are tiny fragments of stone. These may be debris from tool-making by firelight, as people shaped flakes in the evening after gathering food. The image is quiet but powerful, a group huddled near flames, waves crashing below, sparks rising into the night. Stone, fire, and sea meet in the rhythm of survival. From a genetic viewpoint, the spread of populations along coasts aligns with the distribution of tool types. Where stones show certain patterns, DNA confirms related groups. Together, they map the journeys of small communities, branching, separating, reconnecting. Each toolkit carried across a headland or loaded onto a raft is part of this wider map. One unresolved mystery is how much these early stone industries reflect continuity from earlier humans, such as Homo erectus or Homo floresiensis, and how much represents innovation by Homo sapiens. On Flores, Stone tools, older than 1 million years, resemble some of the simpler flakes of later times. Did modern humans copy local traditions, or did they invent anew? The overlap suggests a complex web of influence and coincidence, still being studied. Planetary forces again shaped the story. When seas were low, stone quarries lay open on shelves now drowned. When seas rose, those sources vanished. Groups had to move inland or import stone. This created patterns of scarcity and abundance, visible in the archaeological record. The rise and fall of oceans thus controlled not only land and coastlines, but also the flow of raw materials, shaping the very tools that humans depended on. The importance of stone tools along the ocean edge is therefore more than practical. It is symbolic of how humans engage with their world. Each flake is a moment of thought, a decision to strike one way rather than another. Each scraper is a commitment to future tasks. In the vast silence of prehistory, these are the closest things to words we possess. They are the language of survival, spoken in stone. As the first Australians spread deeper into Sahul, their stone tools accompanied them. In deserts, scrapers shaped digging sticks for roots. In forests, flakes prepared bark for shelters. On coasts, blades sliced fish and shellfish. The continuity of stone technology shows that humans were never without their instruments. They could enter any landscape, however strange, because they carried knowledge in the form of stone. When archaeologists pick up a small flake from a dune or a cave floor, they hold in their hand the trace of a survival decision made 40 or 60,000 years ago. It is humble, yet profound. Without such tools, humans would not have endured along the shifting, uncertain edges of the sea. With them, they thrived, turning coastlines into corridors of life. Along the ancient coasts of Sahul and the scattered islands to its north, survival depended not only on stone tools but also on the gathering of food from sea and shore. Shells, fish, and fire became the essential triad of daily life. Archaeologists find their traces in middens, piles of discarded shells and bones that still lie buried in dunes and caves. These sites reveal meals shared, patterns of foraging, and the quiet endurance of communities who relied on what the sea provided. At low tide, the beach exposed its offerings. Mussels clung to rocks, oysters grew in clusters, and clams buried themselves in wet sand. Children and adults alike could gather them, prying shells loose with sticks or stones. The ease of this work meant that even small groups could secure food without great risk. The middens grow large over time. Layer upon layer of shells discarded after fire cracked them open. These heaps, white against the darker soil, still testify to countless meals. Fish, too, were taken from tidal pools and shallow waters. Traps made of stone or woven reeds guided fish into enclosures as the tide fell. Spears tipped with bone or sharp wood struck at moving schools. Nets may have been woven from plant fibers, though little survives of such fragile tools. Burned fish bones in hearths confirm that this resource was vital. By combining shellfish gathering with fishing, groups ensured steady nourishment even when larger game was scarce. The role of fire in this cycle cannot be overstated. Fire cooked shellfish, softening tough meat and neutralizing toxins. Fire smoked fish, preserving it for later use. Fire warmed damp shelters on windy coasts and lit the darkness of caves. Some archaeologists suggest that fire was even carried between sites, kept alive as embers wrapped in bark or clay. To lose fire meant hardship, to keep it meant continuity. One lesser-known detail emerges from analysis of shell fragments. Heat patterns show that some shells were placed directly in flames, while others were boiled in water heated with hot stones. This variation suggests experimentation. Humans did not use a single method but adapted techniques to circumstance. Such subtle evidence highlights their ingenuity. A single cracked shell can reveal a choice made tens of thousands of years ago. On a planetary scale, reliance on coastal foods fits into a larger pattern. As Ice Age glaciers advanced, inland regions became harsh and dry. Many animals disappeared or retreated, yet coasts remained relatively stable, their tides still bringing fish and shellfish regardless of climate. For humans, the sea was a refuge. It offered a dependable base when other landscapes grew barren. Coastal foraging may have been one of the strategies that carried Homo sapiens through difficult times when populations elsewhere declined. Yet mysteries endure. How much of the diet came from shellfish and fish, and how much from plants or inland animals? Stable isotope studies of ancient bones hint at significant marine consumption, but the picture is incomplete. Rising seas have drowned many sites, erasing crucial evidence. We see only fragments, middens on dunes, hearths in caves, while the majority of the story lies beneath ocean waters. Still, what we do know shows remarkable continuity. At sites in northern Australia, shell middens date back more than 40,000 years. At Lake Mungo, though inland, fish bones indicate a reliance on water resources. In New Guinea, riverine sites preserve evidence of freshwater fishing. Across different regions, the pattern repeats. Water and its life form the heart of subsistence. Humans adjusted methods to each environment but kept the same core strategy. Fire, too, shaped more than meals. Charcoal layers reveal that coastal groups burned vegetation near their camps. Clearing brush reduced pests, encouraged certain plants, and created open space for gathering. These controlled burns show that people managed their surroundings deliberately. Survival was not passive reception of nature's gifts. It was active shaping of the land and seascape to increase abundance. One unresolved scientific question concerns the scale of these practices. Were fires small, limited to camp surroundings, or did they spread widely, reshaping ecosystems? In Sahel, firestick farming is known from later times, but when exactly it began remains debated. Some archaeologists see evidence of large-scale change soon after human arrival. Others argue that broader shifts were caused by climate. The precise balance between human and natural fire is still uncertain. Shell ornaments provide another quiet clue. Some shells found at inland sites bear holes drilled through them. They were carried far from the coast, perhaps as necklaces or tokens. This shows that shell collecting was not only for food, but also for meaning. Ornamentation carried social value. Wearing shells might mark identity, kinship, or memory of the sea. In these small objects, survival and symbolism intertwined. On the scale of daily life, the rhythm of tides guided human action. Camps were set near estuaries, where fresh and salt waters met. Groups learned to move with the moon's phases, timing their gathering to the richest moments. Children watched elders dig in sand or cast spears into pools. Knowledge passed quietly, embedded in practice. Survival along coasts was not a matter of individual skill alone, but of cultural transmission. Archaeological experiments help us imagine the process. Heating stones and placing them in water boils shellfish quickly. Bundles of reeds can trap fish in shallow streams. Fires lit in shell heaps leave layers of ash visible for centuries. These experiments show that even the simplest methods are effective. They help explain how small groups, with limited tools, could live steadily along coasts for millennia. The mystery of preservation also shapes our understanding. Shell middens survive well, but many were washed away or buried. Fish bones are fragile and often destroyed. Wooden tools rot. Fibers vanish. What we see is only a small part of what once was. This incompleteness means that the true richness of coastal life remains hidden. The archaeological record is partial, yet even fragments reveal the ingenuity of those who lived by sea and fire. From the wider perspective of human history, the triad of shells, fish, and fire marks a step toward more complex subsistence. It foreshadows agriculture, where humans deliberately shape food sources. It also foreshadows seafaring, for those who relied on coastal resources often had reason to cross to the next shore. The practices of gathering, fishing, and fire-making formed the foundation upon which later achievements would rest. To stand today on a windy beach where ancient middens lie is to sense this continuity. The sound of waves is the same, the glint of shells in sand is the same. The smell of smoke from driftwood fires would have been the same tens of thousands of years ago. In that stillness, one can imagine families gathered, cooking shellfish, smoking fish, sharing food against the roar of the ocean. Their survival was fragile, yet enduring. It left traces strong enough to last into our time. Far across the Indonesian archipelago lies the island of Flores. Today it is rugged and mountainous, with steep valleys and volcanic peaks rising over the sea. In deep prehistory, Flores was already isolated. Even when sea levels fell at the height of the Ice Age, it remained separated by channels too deep to cross without watercraft. Yet stone tools on the island date back more than 1 million years. This means that some human ancestor reached Flores long before modern humans appeared. The presence of Homo floresiensis, the so-called hobbit, is the lasting trace of that journey. The discovery came in 2003 when archaeologists excavated a limestone cave called Liang Bua. There they found the partial skeleton of a small-bodied human, only about 1 meter tall, with a tiny brain compared to Homo sapiens. Yet alongside the bones lay stone tools, hearths, and animal remains. The evidence was unmistakable. These were humans in every cultural sense, making fire, shaping tools, and surviving on a remote island. Their existence changed the way science understood human evolution. Homo floresiensis is remarkable not just for its size, but for its implications. How did such a species arise? Some scholars believe they descended from Homo erectus, which reached Indonesia long before. Over generations, isolation on an island with limited resources may have caused dwarfing, a well-known evolutionary pattern. Other researchers propose that they represent a more ancient lineage, perhaps closer to Homo habilis. The debate continues. What is certain is that they survived until at least 50,000 years ago, overlapping in time with modern humans. Their tools are small but sophisticated. Simple flakes of volcanic stone, sharp enough for cutting, are found in the same layers as their bones. Some were used to butcher the bones of pygmy elephants, known as stegodon, which once lived on the island. Burned bones show that meat was roasted on open fires. This combination of tools and fire reveals not only survival, but organized lifeways. Even with small brains, Homo floresiensis displayed behaviors long thought to be exclusive to larger-brained humans. A lesser-known detail comes from the animal remains. Flores once hosted giant storks, oversized rats, and Komodo dragons. The hobbits lived among them, hunting some, avoiding others. Rat bones found in caves show signs of cutting, suggesting they were a food source. The presence of Komodo dragons posed constant risk, just as crocodiles did elsewhere. That a small human species endured here for hundreds of thousands of years speaks to remarkable resilience. On a planetary scale, the case of Flores shows how islands act as laboratories of evolution. Animals grow smaller or larger in isolation, adapting to the resources available. Humans, too, were subject to this rule. Just as elephants shrank into stegodons, so perhaps Homo erectus shrank into Homo floresiensis. The island setting magnified evolutionary pressures, shaping bodies and behaviors in unique ways. This demonstrates that humanity's story is not linear, but branching, with each branch shaped by geography and chance. The great mystery is how these early humans reached Flores in the first place. The deep water channels of the Wallace Line separate it from the Asian mainland. Even in periods of low sea level, a crossing of at least 20 kilometers would have been required. No land bridge ever existed. Did a group of Homo erectus accidentally drift on rafts of vegetation torn loose by floods? Or did they construct simple boats from logs and vines? The tools they left cannot answer. But their presence is proof enough that the sea, though formidable, was crossed long before modern humans set sail. The arrival of Homo sapiens in the region may have brought change. Around the time modern humans spread through island Southeast Asia, Homo floresiensis disappears from the record. Did they die out naturally, unable to compete? Did incoming humans bring diseases or new hunting pressures? Or did small populations dwindle on their own, isolated and fragile? This is another unresolved question, one that continues to inspire research and debate. Genetic traces might have helped, but so far, attempts to recover DNA from the fossils have failed in the tropical climate. Without genetic data, the relationship of Homo floresiensis to other humans remains uncertain. Are they a branch of Homo erectus, a relic of a more ancient dispersal, or something entirely distinct? Until new methods succeed, the mystery endures. Still, the presence of these small humans enriches our understanding of survival on remote islands. They remind us that being human has never meant one single form. Intelligence, culture, and adaptability come in many shapes. The hobbits of Flores show that even with small stature and brains, survival over immense spans of time was possible. They used fire. They hunted. They endured isolation. In these acts, they shared much with every other human group. Archaeological surveys on Flores reveal caves beyond Liangbua, where stone tools are also found. Matamenge, another site, preserves tools and fossils even older, perhaps 700,000 years old. These finds suggest that the story of humans on Flores stretches back nearly to the dawn of migration from Africa. Such longevity speaks of continuity, of knowledge passed down across hundreds of generations. Each flake of stone, each ember carried, lives across millennia. The environment of Flores itself shaped these lives. Volcanic soils provided fertile ground for plants, but eruptions were constant dangers. Rivers cut steep valleys, requiring careful movement. Forests were dense, filled with birds and reptiles. In this rugged terrain, Small groups of humans found niches to survive. They did not dominate the island, but they endured within it. Their scale was modest, but their persistence was vast. From a wider perspective, the world of Flores is a reminder of what is hidden beneath today's seas. Countless islands that once hosted human life are now submerged. Flores is exceptional only because evidence there remained above water. The true breadth of early island survival may be much greater than we know. Each new discovery hints at more chapters waiting beneath the waves. In the end, the story of Homo floresiensis is both strange and familiar. Strange because it shows a human species so different from ourselves, small and ancient, surviving on a remote island. Familiar because their lives, gathering food, shaping stone, tending fire, mirror the rhythms of survival shared by all humans. The cave floors of Flores echo with the same patterns of need and endurance that shaped our own ancestors. Today, the caves are silent, their hearths long cold. But in the layers of ash and stone, in the bones of rats and elephants, the traces remain. They tell us that long before modern humans ventured far across oceans, other humans had already found a way. They remind us that the sea, though daunting, has never been an absolute barrier, and they show that survival, in whatever form, is always possible when knowledge and persistence endure. Between the great continental shelf of Sunda and the broad expanse of Sahul lies one of the deepest and most persistent barriers in the world's oceans, the Wallace Line. Named much later by the naturalist Alfred Russel Wallace. This boundary is more than a line on a map. It is the product of geology and climate, of tectonic plates and ancient seas. Even at the lowest sea levels of the Ice Age, when coasts stretched far out and land bridges linked many islands, the Wallace Line remained. Deep channels kept Asia and Australia apart, ensuring that no land connection ever formed. For early humans, this line marked a formidable challenge, one that demanded skill, persistence, and a willingness to step into the unknown. The Wallace Line is more than geography. It divides ecosystems. To the west, on the Asian side, elephants, tigers, and monkeys thrived. To the east, marsupials, giant, flightless birds, and unique reptiles dominated. The division is so stark that even plants and insects differ sharply. For humans, this meant that crossing the line was not only a journey across water, but also a step into a completely different biological world. The species encountered on one side were unlike those on the other. The line therefore represents both a physical and ecological threshold. Stone tools found on Flores, Sulawesi, and other islands show that humans, whether Homo erectus, Homo floresiensis, Denisovans, or Homo sapiens, did indeed cross this line. But how? That remains an enduring mystery. The shortest crossing still required 20 kilometers of open water, with no land visible along the way. Accidental rafting is possible, as floods and storms could have swept groups out to sea on mats of vegetation. Yet the repeated presence of humans on these islands suggests more than chance. It points to deliberate crossings, repeated often enough to establish stable populations. One lesser-known detail comes from Sulawesi. Rock art discovered in its limestone caves depicts animals more than 40,000 years ago, among the oldest symbolic images in the world. This means that by the time humans had crossed the Wallace Line, they were already expressing complex symbolic thought. The journey was not just a physical migration, but also a cultural expansion. Wherever they went, they carried not only tools, but also ideas, rituals, and art. The Wallace Line also shaped the distribution of animals humans depended upon. For hunters, it meant that familiar prey vanished once the crossing was made. Large mammals common in Asia, like pigs and deer, were absent east of the line. Instead, humans encountered marsupials, giant reptiles, and unfamiliar birds. This demanded new strategies. Survival required not just seafaring skill, but also ecological adaptation on arrival. The ability to adjust to entirely new food webs became central to human persistence. On a planetary scale, the crossing of the Wallace Line illustrates how climate and geology frame human possibilities. When glaciers expanded and sea levels dropped, distances between islands shrank, but the deep channels of Wallacea remained. Unlike other parts of the world, no ice age could erase this divide. To cross it was to engage directly with the sea, to build craft, to navigate currents, to understand winds. The fact that humans succeeded reveals their growing capacity to confront natural barriers that no other land animals could pass unaided. Yet mysteries remain. Did modern humans cross the line in one dramatic leap, or in stages over generations? Did they plan routes using visible landmark, or did they follow birds and stars? Some scholars argue for intentional voyaging, guided by observation of seasonal winds and celestial markers. Others see the process as gradual, with groups drifting or being blown off course, then adapting once they reached new islands. The truth may lie somewhere between, accidents that became traditions, experiments that turned into knowledge. Genetic evidence offers clues. Indigenous populations of Australia and New Guinea carry DNA that diverged from other human groups more than 50,000 years ago. This implies that the crossing of the Wallace Line happened early in human dispersal, not as a late expansion. The settlement of Sahul could not have occurred without it. Thus, the Wallace Line is not a footnote, but a central chapter in the story of human migration. Archaeological traces also highlight the continuity of seafaring knowledge. Once humans learned to cross the Wallace Line, they maintained the skill. Obsidian transported across island chains, shells carried far inland, and stylistic similarities in tools across regions all point to ongoing movement. Crossing the Wallace Line was not a single event, but the beginning of a tradition of maritime life that would one day extend across the Pacific. Another lesser-known aspect is the presence of Denisovan ancestry in the DNA of populations east of the Wallace Line. This suggests that encounters with this mysterious human group may have taken place somewhere in Wallacea. No Denisovan bones have yet been found here, but the genetic signal persists. This deepens the mystery, hinting at hidden populations whose traces remain in living people but not yet in the ground. Fire also played a role in these crossings. Carrying embers across open water was not simple, yet evidence from island sites shows that fire was maintained. People may have used clay-lined containers or bundles of bark to preserve embers. This ensured that when land was reached, warmth, cooking, and protection were immediately available. Such details speak to foresight and planning, qualities essential to crossing a barrier as daunting as the Wallace Line. On the ecological side, the Wallace Line remains one of the sharpest boundaries on Earth. Even today, with humans reshaping ecosystems, the division endures. Birds from Asia rarely extend into Australia, and marsupials remain largely confined to the east. For the first humans who crossed, this division was absolute. The journey meant leaving behind the known and entering the strange. Their survival across this divide highlights the adaptability that defines our species. The story of crossing the Wallace Line is, in the end, about thresholds. It is about stepping beyond what is visible, moving into uncertainty, and establishing life in new worlds. It reflects a broader pattern of human history, the willingness to push boundaries, to risk, to adapt. The Wallace Line stands as one of the earliest and most formidable of those boundaries. Today, when scientists look at maps of ancient coastlines, they see the depth of channels, the distances between islands, and the persistence of this divide. Yet for early humans, these were not lines on paper, but horizons on the sea. They looked outward, watched birds fly, read the winds, and trusted in rafts or canoes. Step by step, crossing by crossing, they overcame a barrier that shaped the very distribution of life on Earth. High in the limestone hills of Sulawesi, an island to the east of Borneo, archaeologists have uncovered some of the oldest surviving images made by human hands. Painted in ochre on the walls of caves, they depict animals, warty pigs, anoa, and other creatures of the island. Some are simple outlines, others shaded with careful strokes. Their age is astonishing, more than 40,000 years old, perhaps even older. These images are among the earliest symbolic expressions known anywhere on Earth. They tell us that humans who reached Sulawesi did not only survive, they also created, imagined, and gave meaning to the world around them. The caves themselves are dark and humid. Stalactites drip slowly, and the air smells of minerals and damp earth. To paint here required more than casual effort. People carried torches inside, mixed pigments from iron-rich ochre, and applied them to stone surfaces chosen with care. Hand stencils, made by blowing pigment over outstretched fingers, still cling to the walls. They are signatures across time, silent witnesses that people not only lived on Sulawesi, but also marked their presence in enduring form. A lesser-known detail lies in the style of the paintings. Some animal figures are layered, as if different generations added to them. This suggests continuity, a tradition passed from one group to another. The paintings may have been part of rituals, teaching, or storytelling. They are more than decoration. They reflect an organized symbolic life, embedded in survival strategies. For a people living in island isolation, art became a way to anchor community and memory. The presence of such art raises questions. Did symbolic expression arise independently in different regions, or was it carried from a common origin? Rock art in Europe, such as that in Chauvet and Lascaux, dates to roughly the same period. Were these parallel inventions born of similar cognitive capacities, or were they linked through distant connections along migration routes? Archaeologists debate this mystery. The evidence from Sulawesi shows that wherever humans went, imagination traveled with them. On a planetary scale, these discoveries remind us that symbolism is not bound to a single continent. It is a universal trait of Homo sapiens, appearing in Africa, Europe, Asia, and Australia. The rhythm of glaciers, the rise and fall of seas, did not prevent symbolic thought from flowering. Even as coastlines shifted and islands were isolated, people continued to mark walls with pigment and meaning. The world's changing geography shaped survival, but the urge to create endured across barriers. The ecological setting of Sulawesi also matters. The island lay within Wallacea, separated by deep seas from both Sunda and Sahul. To reach it, humans had already crossed formidable waters. The fact that symbolic art appears here means that the skills of seafaring and the capacity for symbolism coexisted. Those who braved currents and winds also painted animals on stone. Their survival was physical, but it was also cultural. They adapted to landscapes and also transformed them into landscapes of the mind. The animal figures themselves hold information. Warty pigs are shown with distinctive crests and tusks. These details prove that artists observed closely, capturing traits that identify species with precision. Such attention to animals may reflect their role in subsistence. Hunting them provided food, hides, and bone. Painting them may have reinforced knowledge of behavior or carried ritual significance linked to hunting success. The art thus connects ecology with symbolism, need with expression. One unresolved mystery is why the art was made in caves rather than open spaces. Perhaps caves offered protection from weather, preserving images for millennia. Perhaps darkness itself was part of ritual, creating a space apart from daily life. Or perhaps the acoustics of caves, with echoes and resonances, added power to ceremonies held within. We cannot know the full reasons, but the choice of caves was deliberate, shaping the survival of images across tens of thousands of years. The pigments used tell another story. Ochre, ground from iron-rich earth, was mixed with water or saliva to form paint. In some cases, binders, like plant resins, may have been added. The act of preparing pigment shows technical skill. It also suggests planning. Ochre had to be gathered, carried, and stored. In some caves, deposits of pigment dust suggest workshops where colors were ground repeatedly. This implies not one-time acts, but traditions of art-making that span generations. From the perspective of human evolution, Sulawesi's rock art shows that symbolic thought had already matured long before agriculture or cities. These people lived as hunter-gatherers, dependent on shells, fish, and forest game. Yet their minds reached beyond immediate needs. They created images that endured beyond their own lives. In this sense, symbolic behavior was as essential to survival as fire or tools. It bound communities together, gave meaning to landscapes, and carried knowledge across time. The world outside the caves was equally dynamic. Rising and falling seas shifted coastlines. Rivers carved valleys. Forests grew and burned. Amid these changes, rock art provided continuity. Hand stencils, identical in form, appear across different caves. They suggest that identity and belonging were expressed through these marks. Each handprint said, "We were here. We are part of this place." For a small group on a remote island, such statements may have been crucial to resilience. Another lesser-known aspect is that Sulawesi's art includes not only animals but abstract forms. Dots, lines, and patterns accompany figures. These may represent counting, mapping, or symbolic signs. Their meaning is lost, but their presence shows that thought extended beyond the visible world. Abstraction is as much a part of humanity as depiction. The coexistence of both in Sulawesi reveals a complex symbolic system, not merely isolated acts of painting. On the genetic side, modern populations in Wallacea carry traces of both ancient migrations and later movements. They bear signals of Denisovan ancestry, linking them to encounters elsewhere in the region. The art of Sulawesi sits within this web of contact. It shows that symbolic culture was not confined to Africa or Europe, but was thriving among populations who also carried unique genetic histories. Culture and biology intertwined, shaping both survival and identity. A planetary observation emerges here as humans spread across Earth. Symbolism did not fade in isolation. It strengthened, whether in the caves of Sulawesi, the cliffs of Spain, or the rocks of Arnhem Land in Australia, humans painted, carved, and marked their worlds. This persistence shows that symbolic life was not an optional addition, but a core feature of our species. Even as seas drowned coasts and glaciers advanced, the impulse to create never disappeared. The mystery of Sulawesi's art remains partly unresolved. How widespread was symbolic culture across Wallacea? How much has been lost to erosion, tropical weather, or rising seas? Only fragments survive, yet each new discovery expands the map of early imagination. The hand stencils and animal figures remind us that art is as ancient as migration itself. Standing today at the entrance of Liang Bua, or Liang Tedonge, where these paintings survive, one feels the continuity of human presence. The walls are marked by hands no different in shape from ours. The animals, though painted long before memory, still appear familiar. Across 40 millennia, the images bridge lives, showing that early humans on remote islands were not only survivors but also creators. They endured with shells, fish, and fire, but also with stories painted in ochre. On islands scattered across Wallacea and Sahul, the rules of life bend in unusual ways. Isolation, limited resources, and the absence of predators create conditions unlike those of vast continents. Animals respond to these pressures with striking changes. Large creatures shrink in size, while small ones grow larger. This is the pattern known as the island rule, and its consequences are written clearly in the fossil record of ancient islands. For early humans, this biological reshaping altered the very strategies of survival. To live on islands meant adjusting not only to strange landscapes but also to creatures transformed by isolation. One of the most famous examples is the stegodon of Flores. These relatives of elephants once roamed Asia as giants, but on Flores, their descendants became dwarfs, no larger than a cow. Fossil remains show individuals barely 1 meter tall at the shoulder. For Homo floresiensis, the hobbits of the island, these stegodons were both food and challenge. Though small compared to continental elephants, they were still large enough to demand cooperation in hunting. Burned bones suggest that fire was used to cook their meat. The shrinking of such a massive animal changed the balance of prey and predator on the island. At the same time, smaller animals often grew larger. On several islands, rats reached sizes comparable to cats. These giant rodents became a steady food source for human groups. Cut marks on bones found in caves confirm they were eaten. Their abundance meant reliable protein in places where large game was scarce. Yet their size also carried risk. Larger rodents could damage stored food or compete with humans for resources. Survival required management of both benefit and threat. Reptiles followed similar paths. On islands with few large mammals, lizards and snakes filled ecological roles. Komodo dragons, found on Flores and nearby islands, grew to lengths over 3 meters, the largest living lizards on Earth. For humans, these predators demanded caution. Camps had to be placed carefully, and water sources approached with vigilance. At the same time, their skins and bones may have provided materials. Living alongside such giants shaped patterns of movement and settlement. Birds, too, changed under island conditions. On Sahul, enormous flightless birds like Genyornis stalked the plains, weighing over 200 kilograms. Their eggs, large and nutrient-rich, were gathered by humans. Burned fragments of shells suggest repeated harvesting. Over time, the birds disappeared, perhaps unable to withstand pressure from both hunting and climate. On smaller islands, other birds grew outsized, filling niches left empty by mammals. The diversity of avian life presented humans with opportunities and challenges, shaping their diets and strategies. A lesser-known detail emerges from Timor, where archaeological sites reveal remains of giant rats alongside fish bones. These show that humans adjusted easily to mixed diets, combining terrestrial and marine resources. Such flexibility was key to endurance. By exploiting both land and sea, people could survive even when one source faltered. The presence of island dwarfs and giants meant that no two islands offered the same balance of food. Each arrival demanded fresh learning. On a planetary scale, island evolution reflects the dynamic forces that shape life everywhere. As glaciers locked up water, sea levels fell, connecting some islands while leaving others isolated. Populations of animals trapped on these isolated lands adapted in unique ways. For humans, who moved across coasts and seas, this meant entering worlds of constant novelty. The experience of migration was never uniform. Each crossing brought a different set of creatures, a different ecology, a different balance of risk and reward. The mystery lies in how humans responded to these shifting ecologies. Did they deliberately target large, slow-reproducing animals, accelerating extinctions? Or did they focus on smaller, more abundant prey, letting giants vanish through climate change alone? The archaeological record offers partial answers. Burned eggshells, cut-marked bones, and charcoal layers point to human impact. Yet the full scale of responsibility is debated. What is certain is that the presence of humans coincided with rapid ecological change. Genetic studies of modern populations show how small founding groups survived amid such transformations. DNA reveals bottlenecks, moments when populations shrank to low numbers, yet endured. This mirrors the fragility of island ecosystems. Just as a single storm can alter a shoreline, so a single failed season could threaten survival. Humans persisted by being generalists, eating many foods, adapting quickly, shifting strategies when needed. The island rules shape not only animals but also human behavior. Another intriguing aspect is the use of fire. On islands where grassland supported dwarf herbivores, humans may have used burning to encourage regrowth and attract prey. Charcoal deposits suggest controlled fire was practiced in many regions. This further altered ecosystems, creating mosaics of open and closed habitats. Such practices, repeated over centuries, likely accelerated the pace of ecological change. In this way, humans became active participants in the evolutionary drama of islands. The symbolism of animals also mattered. Rock art in Sulawesi and Arnhem Land includes depictions of local species, some no longer alive. Painting or carving these creatures suggests they carried meaning beyond food. They may have been subjects of myth, ritual, teaching. Even as island animals changed in size and form, humans integrated them into cultural memory. In this sense, survival was not only biological, but also symbolic. Knowledge of animals was preserved in stories and images as well as in practice. On a broader scale, the story of dwarfs and giants shows how interconnected humans were with planetary processes. Rising seas cut populations apart. Climate shifts altered vegetation. Humans arrived, bringing fire and hunting, each factor wove into the tapestry of change. The result was a pattern unique to islands, strange creatures, fragile ecologies, and humans adapting endlessly. This interplay highlights the delicate balance between isolation and connection, between survival and extinction. One unresolved scientific mystery concerns the speed of these transformations. Did stegodons shrink rapidly after being stranded, or did the process take hundreds of thousands of years? Did human hunting push them to extinction quickly, or did populations linger in pockets long after? Fossils offer glimpses, but precise timelines remain unclear. Each new discovery refines the picture, but much is still hidden beneath layers of earth or drowned beneath seas. For early humans, however, the practical reality was immediate. They stepped ashore on islands where elephants had become cow-sized, where rats had become predators of grain, where lizards grew larger than any mammal. They adapted without hesitation. They learned which species to hunt, which to avoid, and which to revere. In doing so, they wove themselves into island ecologies that were at once strange and fragile. Today, the fossils of dwarfs and giants remind us of this ancient resilience. Bones of stegodons, shells of giant birds, and teeth of rodents still lie in caves and sediments. They speak of vanished worlds, where humans survived not by forcing the land into uniformity, but by adjusting to its peculiarities. Each island demanded a new way of life, and each way of life was sustained long enough to leave traces for us to find. The island rule, expressed in the shrinking and swelling of animals, shaped the encounters of humans with their environments. It taught them adaptability, observation, and respect for limits. It showed them that survival required attention to every detail, from the size of a rodent to the clutch of a bird. In this way, the dwarfs and giants of islands were not curiosities, but partners in the long story of human endurance. As the Ice Age unfolded and glaciers waxed and waned, and with each cycle the seas rose and fell. When ice locked water on the continents, the oceans retreated, exposing vast shelves. Islands joined into larger landmasses, and humans walked freely across plains that are now submerged. But when the climate warmed again, ice melted, seas rose, and shorelines crept inland. The world of early humans was never stable. It shifted with the pulse of climate, sometimes slowly, sometimes in sudden surges. For those living on coasts and islands, this meant that the ground beneath their feet was never permanent. Archaeological evidence shows how profound these changes were. In Southeast Asia, entire regions of the Sunda Shelf, now hidden beneath the South China Sea, the Java Sea, and the Gulf of Thailand, once stood above water, forests, rivers, and savanna stretched where waves roll today. Human groups lived there, hunted, gathered, and left tools. All of it is gone, drowned beneath rising seas after the last glacial maximum. What remains are fragments on higher ground, caves, terraces, and cliffs that escaped submergence. The rest of human coastal history from this period is invisible, erased by water.
On Sahul, the same forces reshaped the coasts. When humans first arrived, shorelines extended far out. Rivers drained across wide plains, forming fertile estuaries. Over time, seas advanced, drowning those plains and pushing people inland. Camps that once stood at the edge of water found themselves far from shore, while others were swallowed entirely. The archaeology we see today is a mere fraction of what once existed.
A lesser-known detail emerges from studies of shell middens. Some are found kilometers from today's coasts, stranded in arid interior regions. Their presence reveals that when they were created, the sea was much closer. People had gathered shellfish on beaches that no longer exist, then abandoned their camps as the sea withdrew. These stranded middens serve as silent markers of shifting shorelines, testimonies to a coastline that moved endlessly back and forth. The planetary mechanism behind these changes was the rhythm of glacial cycles. Driven by shifts in Earth's orbit, ice sheets grew and melted over tens of thousands of years. Each advance locked away water, each retreat released it back to the ocean. For humans, these cycles determined not only climate and vegetation but also geography itself. A land bridge might exist for generations, linking populations. Then, within a few lifetimes, it would vanish, cutting communities apart. One unresolved scientific question concerns the speed of these changes. Were sea level rises always gradual, giving groups time to retreat? Or were there sudden pulses, catastrophic floods that forced rapid abandonment of coastal lands? Geological studies show evidence of both. Meltwater pulses at the end of the last ice age raised seas by meters within a century. Such events would have transformed coastlines dramatically within a single human lifetime. Oral traditions from later societies sometimes recall floods and vanished lands, suggesting that memory of these shifts lingered for generations. The shrinking of shores shaped human survival strategies. Populations that had relied heavily on coastal resources found themselves forced inland, seeking rivers and lakes to replace the sea. Others learned to adapt, moving camps repeatedly as shorelines advanced. Fire played a role, clearing new ground as forests grew where beaches had been. Fishing strategies shifted, focusing on rivers when tidal flats vanished. The constant need to adapt taught flexibility, a hallmark of human resilience. On a broader scale, rising seas also severed connections between regions. Tasmania, once linked to mainland Australia, was cut off around 10,000 years ago. Populations stranded there developed in isolation, maintaining traditions but separated from others. Similar processes occurred throughout island Southeast Asia. Each rise of sea level turned peninsulas into islands, creating fragmentation. Humans adjusted, but the networks of movement that once spanned open plains were fractured. Another lesser-known aspect comes from genetic studies. Populations on islands often show reduced diversity, reflecting these isolations. When seas rose, groups became cut off, and gene flow diminished. Over time, this left distinctive genetic signatures still visible in modern peoples. The rising seas thus not only erased archaeological sites, but also reshaped the biological history of humanity. The mysteries of drowned landscapes remain. What lies beneath the Java Sea or the Arafura Sea? Could ancient camps, tools, or even symbolic sites still be preserved under layers of silt? Marine archaeology has only begun to explore these possibilities. Sonar mapping reveals drowned river channels, deltas, and terraces, places where people once lived. Each discovery hints at vast hidden chapters of human history waiting beneath the waves. On the scale of daily life, these changes meant that families and communities lived with impermanence. A camp built near a river mouth might serve for decades, only to be abandoned as tides encroached. Trails once leading to beaches became paths into water. Children grew up watching landscapes alter within their lifetimes. This constant movement left its mark on human memory, reinforcing traditions of mobility and adaptation. The symbolism of water may also have been shaped by these experiences. Myths and rituals surrounding floods, the sea, and vanishing land appear in later cultures across the world. Some scholars suggest these reflect deep memories of Ice Age sea level rise. While the evidence is indirect, the persistence of such stories highlights how strongly rising waters influenced human imagination. The ecological consequences of shrinking shores were also profound. Estuaries rich in fish and shellfish vanished, reducing reliable food sources. Mangrove forests expanded or retreated with the tides, altering habitats for birds and reptiles. Humans had to follow these changes closely. Some groups shifted to more terrestrial diets. Others intensified fishing in rivers and lagoons. Each adjustment left traces in the archaeological record: new tools, new food remains, new settlement patterns. One unresolved debate concerns the impact of these changes on population size. Did rising seas reduce human numbers by stranding and isolating groups, or did adaptability allow populations to thrive despite loss of land? Genetic bottlenecks suggest that numbers may indeed have dropped in some regions. Yet the persistence of continuous lineages in Australia and New Guinea shows that survival was never fully broken. Small groups endured, preserving traditions across millennia of shifting coastlines. From a planetary perspective, the story of rising seas is still unfolding. The processes that shaped Ice Age coasts continue today. As glaciers melt in our time, seas rise again, threatening to drown coasts where millions now live. The echoes of the past remind us that humans have faced such changes before. The difference lies in scale and speed. For early humans, small groups could retreat inland. For us, the challenge is global. Yet, in the quiet of prehistory, the rhythm of advancing seas was part of life. People did not see it as catastrophe, but as another shift in the world they inhabited. They moved, adapted, and endured. The traces they left, middens far inland, stone tools stranded in dry valleys, genetic signatures in isolated populations, tell us how survival was achieved. Standing on today's coasts, we can imagine those earlier worlds. The beach, far offshore. The river, flowing through plains now drowned. The campfires, flickering where waves roll today. The shrinking of shores was not the end of human presence. It was the beginning of new adaptations, new routes, and new ways of life. On remote islands and shifting coasts, early humans did not live in isolation as completely as the geography might suggest. Archaeologists uncover scattered traces that point to networks, links of stone, shell, and pigment that extended across distances of sea and land. These objects, traded, carried, or exchanged, reveal that even small island groups were part of wider webs of connection. For survival, it was not enough to know the local ecology. People also relied on ties that stretched outward, reaching across waves and valleys. One of the clearest signs of these networks is obsidian. This volcanic glass, sharp and glossy, makes excellent cutting tools. But it is not found everywhere. In the Bismarck archipelago, obsidian sources lie on only a few islands. Yet archaeological sites hundreds of kilometers away contain obsidian flakes. This means that people carried it, either through direct voyaging or through chains of exchange. The distances involved are far beyond a day's walk. They required water travel and deliberate effort. Such movement demonstrates that humans maintained connections even across isolation. Shell ornaments provide another strand of evidence. Beads and pendants carved from marine shells appear far inland, sometimes more than 100 kilometers from the coast. They were drilled, polished, and worn as decoration. Their presence in interior sites shows that shells traveled, passed from hand to hand. These objects were more than adornment. They embodied links between coast and upland, between one group and another. A shell bead could signal identity, kinship, or alliance. It carried meaning as well as beauty. A lesser-known detail comes from New Guinea highlands. Here, stone mortars and pestles, intricately carved, date back thousands of years. Some are made from materials not local to the immediate area. This suggests movement of goods along mountain routes. Connecting distant valleys, even in rugged terrain, people sought exchange, carrying heavy stone objects through forests and across rivers. These acts show that the idea of networks extended beyond the coast, linking highland and shore in complex patterns. On a planetary scale, such networks mirror a universal human trait. From Africa to Eurasia, from the Americas to Oceania, humans have always forged connections beyond immediate groups. Exchange spreads not only materials, but also ideas and practices. Shells and stones serve as vehicles of memory and knowledge. They create bonds that stretch across landscapes. In the shifting world of Ice Age seas and islands, such bonds were crucial to resilience. The mysteries remain in the details of how these exchanges occurred. Were they the result of direct journeys by seafaring groups? Or did objects move gradually, passed between neighboring communities over generations? The archaeological record alone cannot always answer, but the regularity of distribution, the consistency of styles, and the distances involved suggest organized systems. These were not random dispersals, but deliberate networks of interaction. Genetic studies add depth to this picture. Populations in island Southeast Asia and Oceania carry traces of shared ancestry, even when separated by seas. This indicates that people did not remain fully isolated after initial settlement. Instead, there was continued movement, continued contact. Genes, like obsidian and shells, flowed across the networks. The survival of small populations was strengthened by these ties, reducing the risks of isolation. One unresolved question concerns the scale of social complexity implied by these exchanges. Did networks involve large gatherings, or with ceremonies and negotiations? Or were they maintained by small-scale, kin-based visits without written records? It is difficult to know, yet the presence of ornaments and valued stones suggests that relationships mattered as much as resources. Exchange was not simply practical, it was also symbolic, reinforcing trust and connection. Another important aspect is the role of symbolic objects themselves. Shell beads, for example, are often found in burials. This indicates that they were valued beyond life, placed with the dead as tokens of identity or belief. Similarly, ochre used in rock art may have traveled from distant sources, chosen for particular colors. These practices show that networks were not only about survival in material terms, but also about sustaining symbolic worlds. Fire, too, may have played a role in exchange. Knowledge of how to carry embers, how to kindle flames, how to use plants for fuel, could have spread through contact. When groups met, they shared not only objects, but also techniques. The networks thus carried both tangible goods and intangible knowledge. In this way, human survival was enriched by connection, not limited to local invention. On islands where resources were scarce, these networks became lifelines. A group cut off by storm or shortage could reach out through exchange. A rare stone, a shell ornament, or a pigment source could bind one community to another. Such ties spread risk, ensured diversity of resources, and reinforced cooperation. Survival was not only a matter of adaptation to environment, but also of integration into a wider web of human presence. A lesser-known example comes from early lapita sites, though later in time, where pottery and obsidian show long-distance exchange across the Pacific. These practices, though younger, echo the patterns first glimpsed in Wallacea and Sahol. They suggest continuity of maritime networking, a tradition rooted deep in prehistory. The seeds of oceanic exchange were already present in these earliest movements. On the planetary level, the presence of networks challenges the image of early humans as isolated bands. Instead, they appear as interconnected communities, even across barriers of sea and mountain. This interconnectedness foreshadows later developments, trade routes, cultural exchanges, shared technologies. The foundations of global human culture lie in these early networks of stone and shell. The archaeological record is incomplete, but each fragment adds to the picture. An obsidian blade on a distant shore, a shell bead in a mountain burial, a pigment trace in a cave, each is a node in a web. Together they reveal that even in remote times and places, humans did not live alone. They reached outward, carried objects, exchanged meaning, and built connections. Standing today in the highlands of New Guinea or on the coasts of Sulawesi, one can imagine these ancient journeys. A canoe loaded with stone paddled across a channel. A shell passed from hand to hand, carried inland along trails. A pigment traded for food, later painted on a cave wall. Each act small, yet each contributing to a vast pattern of continuity. These networks ensured that survival was not only possible, but sustainable. They spread resources, ideas, and identity. They wove scattered islanders into a fabric of connection. And they show us that even in the most remote corners of prehistory, humans were never fully apart. They were always part of something larger, a web of exchange that stretched as far as their eyes could see and their boats could carry them. Life on remote islands carried with it a particular fragility. Populations that managed to cross seas and establish themselves often began with only a handful of families. Once settled, they lived with limited numbers, their survival balancing on the edge of chance. Archaeologists and geneticists today trace the echoes of these small beginnings. The evidence shows that for tens of thousands of years, human communities endured in low population densities, shaped by both opportunity and risk. Genetic studies reveal clear signs of bottlenecks. Populations in Sahul and surrounding islands show reduced diversity compared to continental groups. This reflects the reality of their founding. A small number of voyagers crossed the Wallace Line, and all their descendants carried only the genetic variation they brought. Over time, this narrow base left marks still visible in living peoples. Despite isolation, these communities endured for millennia, a testament to resilience under constraint. Archaeological traces reinforce this picture. Camps are small, hearths few, and food remains limited in scope. On many sites, the scale of activity is modest, suggesting groups of dozens rather than hundreds. Middens grow slowly, hearths are scattered, and artifacts are few. These are the signs of life lived in small circles, with each family crucial to the survival of all. Unlike the large settlements that would later emerge with farming, these groups survived through flexibility and kinship. A lesser-known detail comes from burial sites. In some cases, skeletons show evidence of inbreeding, such as unusual bone structures. This is consistent with small, isolated populations where close relatives sometimes became partners. Though risky, such practices were part of survival. The alternative might have been extinction. Genetic bottlenecks carry costs, but they also ensured continuity in places where contact was rare or absent. On a planetary scale, the persistence of small populations reflects a larger theme of human prehistory. Our species did not always number in millions. For much of the past, survival depended on scattered groups living at the edge of endurance. Climatic shifts reduced habitable land, disease spread quickly in close quarters, and accidents could eliminate entire families. Yet humans endured, not through vast numbers, but through adaptability and cooperation. Mysteries remain about the precise sizes of these founding groups. How many people were needed to colonize Sahel successfully? Some models suggest as few as a few hundred individuals. Others argue for repeated voyages over centuries, bringing new members into the gene pool. The archaeological record is too incomplete to decide. Yet the genetic signals are clear. Small numbers played a central role in shaping the ancestry of millions today. Survival in such conditions required strategies beyond simple hunting and gathering. Knowledge had to be shared and preserved. A single lost skill, how to make fire, how to cross water, how to find edible plants, could endanger an entire community. Oral transmission became essential. Elders taught children, who in turn passed knowledge forward. Cultural continuity acted as a safeguard against the vulnerabilities of small populations. The ecological context of islands heightened these pressures. On large continents, groups could move when resources failed, joining others or finding new territory. On islands, choices were limited. Drought, storm, or disease could devastate communities. To endure, people diversified their food strategies. They gathered shellfish, hunted small game, fished rivers, and foraged for plants. Redundancy in diet reduced the risk of collapse. This strategy is visible in archaeological layers, where shells, fish bones, and plant residues are often mixed together. Another lesser-known aspect is the evidence of symbolic practices even in small populations. Rock art, ornaments, and ochre use appear even where numbers were low. This suggests that symbolism was not a luxury of large groups but a necessity. Rituals, stories, and art reinforced identity and cohesion. In fragile communities, cultural meaning bound individuals together, providing stability when numbers alone could not. On the genetic side, the effects of small populations sometimes produced unique traits. Certain lineages of mitochondrial DNA, rare elsewhere, became common in island groups. These markers persist in living descendants, offering windows into ancient survival. The fact that such lineages survived at all shows the continuity of life under challenging conditions. The unresolved mystery is how much contact existed between islands after initial settlement. Did small populations remain isolated for thousands of years, or did periodic voyages bring in new members? The presence of obsidian and shell ornaments suggests at least some contact, but whether this was regular or occasional remains uncertain. The balance between isolation and exchange shaped both biology and culture. On a broader planetary level, small populations on islands mirror the fragility of early humans everywhere. Around 70,000 years ago, our species itself may have been reduced to a few thousand individuals after the Toba eruption. Survival in small numbers is therefore not unusual in human history. It is the norm from which larger populations later grew. The story of islanders is a local version of this global pattern. Archaeological case studies reinforce this theme. In Tasmania, once connected to mainland Australia, isolation set in around 10,000 years ago. Populations there remained small for millennia, preserving unique traditions while cut off from others. In the Bismarck archipelago, genetic studies show founder effects, where rare traits became common due to limited ancestry. Each example highlights the precarious balance of survival in small groups. Daily life under such conditions must have been shaped by cooperation. Each member mattered: a skilled toolmaker, a knowledgeable gatherer, or an experienced navigator carried knowledge essential to the group. The loss of one person could weaken survival prospects. Social bonds were therefore not optional, but central. Kinship networks ensured that tasks were shared, risks distributed, and memory preserved. The use of fire again reflects this reality. Keeping embers alive meant avoiding the difficult task of igniting flames anew. In small groups, the responsibility might fall to a single caretaker. The loss of fire could mean hunger or exposure. Archaeological traces of hearths suggest that maintaining fire was a consistent priority, even in the smallest camps. From another perspective, the symbolic role of animals and landscapes may have helped communities persist. Rituals linked people to their environment, giving meaning to survival. Rock art on Sulawesi, hand stencils in caves, and ochre pigments in burials all show that cultural practices were not abandoned, even under stress. Instead, they became anchors for identity. Ultimately, the story of survival in small numbers is a story of persistence. Populations on islands may have been reduced to a few hundred or less, yet they endured through knowledge, cooperation, and symbolic life. Their genetic legacy flows in millions today. Their cultural traces remain in art, ornaments, and hearths. Their existence shows that survival does not require vast numbers, only continuity and adaptability. On the planetary scale, this resilience shaped the future. From small island groups, entire lineages expanded. From fragile beginnings, vast cultural traditions grew. The survival of small populations ensured that humanity spread to every continent and ocean. Their story is the foundation of ours. The timing of human migrations into the scattered islands of Southeast Asia and onward to Sahul remains one of the most contested subjects in archaeology. Each discovery shifts the timeline slightly, suggesting either earlier or later arrivals. Some sites point to occupation as far back as 70,000 years ago, while others support more cautious estimates of 50,000. The uncertainty reflects both the difficulty of preserving evidence in tropical climates and the drowning of vast coastal areas by rising seas. Yet even amid these gaps, the broad outline is clear. Humans made the crossing earlier than once believed, and their settlement transformed both landscapes and cultures.
At Madjedbebe in northern Australia, stone tools, hearths, and ochre fragments date to at least 65,000 years ago. This makes it the oldest known site in Sahul, pushing human arrival back further than earlier assumptions. The implications are profound. If people reached Australia so early, then the journeys across Wallacea and the Wallace Line must also have taken place at least that long ago.
This raises the question of whether humans left Africa, spread eastward sooner than traditional models suggest. On the other hand, other sites complicate the picture. Some researchers caution that dating method, especially for very old deposits, can yield wide ranges of error. In a few cases, layers may have been disturbed by natural processes, mixing younger and older material. Critics argue that while 65,000 years is possible, the more secure range is closer to 50,000. These debates highlight the challenges of working with fragmentary evidence. The exact timing remains unresolved. A lesser-known but significant detail comes from Sulawesi. Rock art discovered there has been dated to at least 45,000 years ago, making it the earliest known figurative art in the world. For humans, To be painting animals on cave walls at that time, they must have already been well established on the island. This implies an earlier arrival than the art itself records. The creative expressions are therefore indirect testimony of deeper histories. They show that humans were not just passing through, but living, thriving, and creating meaning. Genetic evidence adds another layer. Studies of modern populations in Australia, New Guinea, and island Southeast Asia reveal lineages that diverged from other human groups around 50 to 60,000 years ago. These findings align with archaeological claims of early settlement. The DNA suggests that once established, these populations remained relatively continuous, preserving one of the deepest unbroken lineages outside Africa. For scientists, this genetic continuity is one of the strongest arguments for early arrival. On a planetary scale, these debates connect to broader climatic events. Around 74,000 years ago, the Toba supereruption in Sumatra spread ash across large parts of Asia. Some models once suggested that this eruption caused a severe bottleneck in human populations, limiting expansion. Yet the presence of early humans in Sahul indicates that groups survived and dispersed despite such challenges. The resilience of migration amid catastrophic events demonstrates the adaptability of our species. The unresolved mystery lies in the pace of these movements. Did humans cross Wallacea in a rapid series of voyages, reaching Sahul within a few generations? Or was it a slow spread, with groups pausing for centuries on one island before moving on? Archaeological records show long occupations on Flores and Sulawesi, suggesting that settlement, not just transit, took place. Yet the distances covered, the challenges of deep water crossings, and the early dates in Australia imply that at least some movements were swift. Obsidian artifacts provide further hints. In the Bismarck Archipelago, obsidian from known volcanic sources appears in sites hundreds of kilometers away, dated to more than 30,000 years ago. This proves that maritime exchange networks were already functioning by that time. If such networks existed later, perhaps their foundations were laid earlier, when humans first moved through Wallacea. The presence of traded materials points to intentional voyaging, not accidental drift. Another puzzle is the role of other human species. Homo floresiensis survived on Flores until at least 50,000 years ago. Denisovan ancestry persists in modern populations of Oceania, showing that encounters occurred somewhere in this region. Did modern humans meet and interact with these groups during their migrations? If so, what was exchanged? Genes, technologies, or symbolic practices? The timing of these contacts is uncertain, but their existence complicates the narrative. Migration was not only movement into empty lands, it was entanglement with others. A lesser-known aspect of the debate comes from drowned landscapes. When sea levels were lower, the Sunda Shelf and Sahul Shelf formed vast land masses separated by Wallacea. The coastal plains of these shelves would have been prime locations for settlement. Today they lie underwater, erasing much of the record. Marine archaeology has only begun to explore them. Sonar mapping reveals drowned rivers and valleys that could have supported life. The timing of migration is thus hidden beneath waves, awaiting exploration. On the scale of daily life, the uncertainty of timing may not have mattered to those who lived it. For the families who set out across water, survival was the focus. They carried fire, tools, and knowledge, stepping into unknown coasts. Whether their voyage occurred 65 or 50,000 years ago changes little in their experience. What matters is that they succeeded, establishing lineages that persist to this day. Still, for science, The precision matters. Each year, gained or lost in the timeline, reshapes our understanding of human capacity. An arrival 65,000 years ago suggests that seafaring and symbolic life developed earlier than expected. A later arrival fits more comfortably within existing models but raises questions about how humans reached Sahul so quickly afterward. The debate continues, driven by new methods and new finds. From a wider perspective, these uncertainties highlight the nature of prehistory itself. The record is fragmentary, subject to erosion, submergence, and chance preservation. Each discovery shifts the picture, often dramatically. The search for timing is not merely academic, it reflects humanity's effort to trace its own path through deep time. To know when we reached new lands is to know something of who we are. One unresolved question remains particularly intriguing. Was there more than one wave of migration? Some genetic models suggest repeated dispersals, with early groups replaced or absorbed by later ones. Others argue for a single, successful colonization. The archaeological record could support either, depending on interpretation. This mystery lingers at the heart of the debate. Ultimately, though, the story of migration timing is one of endurance. Whether early or later, humans crossed formidable barriers and established themselves in distant lands. The seas rose, coasts vanished, and climates shifted, yet the descendants of those voyagers remain. The precise dates may remain contested, but the achievement itself is beyond doubt. Humanity reached Sahul, lived among its unique animals, and carved out one of the longest continuous cultural histories in the world. On a planetary scale, the debates remind us of the fragility of evidence and the persistence of human survival. The clocks of archaeology and genetics tick differently, but together they outline the broad truth. Early humans moved further and faster than once believed. The unresolved details are shadows cast by the ocean's depth and time's erosion. In the end, what matters is the continuity of life. Across millennia, people lived, gathered food, painted walls, and passed knowledge to their children. Whether their ancestors stepped ashore 65 or 50,000 years ago, the legacy is the same: survival in new lands, adaptation to strange ecologies, and the endurance of human presence against the shifting rhythms of the planet. When the last ice age came to a close, the seas rose once more, reclaiming land that had been exposed for tens of thousands of years. Vast plains that had once connected islands disappeared beneath the waves. Shorelines retreated, forests drowned, and human camps vanished without a trace. For archaeologists, this has created one of the greatest silences in the record of prehistory. What remains of early coastal life is fragmentary, scattered on higher ground or preserved in caves. Most of the evidence lies hidden under oceans, unreachable except by the most challenging methods. The echoes of vanished shores linger in fragments of shell, in scattered tools, and in the faint memory of landscapes long gone. The loss of these sites is profound, and consider the Sunda Shelf, which once stretched from mainland Southeast Asia to Java, Sumatra, and Borneo. During the height of the Ice Age in this region was a vast landmass, rich with rivers, lakes, and coastal wetlands. Humans almost certainly lived there, gathering resources and traveling across its expanse. Yet as the glaciers melted, the shelf was inundated. Today it lies beneath shallow seas, its history inaccessible to all but marine archaeology. What stories remain there, camps, hearths, ornaments, are sealed away by water and time.
On Sahul, too, the coasts were transformed. When humans first arrived, northern Australia extended far beyond its present line. forming fertile estuaries and wide plains. People fished, gathered shellfish, and built fires there. Now those landscapes are drowned beneath the Arafura and Timor seas. In New Guinea, similar plains disappeared as waters rose, cutting the island off from its neighbours. The people endured, but their earliest settlements are gone, erased by the sea.
A lesser-known detail comes from inland shell middens, stranded far from today's coastlines. These accumulations of shells mark places where people once lived beside the sea. As waters retreated or advanced, they were left behind, silent witnesses to shifting shorelines. For archaeologists, they are precious clues, hints of the vast coastal lifeways now lost. Each shell carries the memory of a tide, a meal, a fire shared long ago. On a planetary scale, say, the drowning of early coasts illustrates the power of climate to shape human history. As ice melted, global sea levels rose by more than 100 meters. Coastlines shifted across every continent, erasing settlements from Africa to the Americas. The pattern was universal. Wherever humans had lived near the sea, their earliest sites are now hidden. The story of human expansion is therefore incomplete, filtered by the preservation of land that remained above water. This loss fuels one of the central mysteries of prehistory. How much did we once rely on coasts, and how far did we travel along them? The coastal migration theory proposes that early humans moved rapidly out of Africa by following shorelines, living on fish and shellfish, and crossing short water gaps. If true, much of that evidence now lies underwater, explaining why traces of such journeys are rare. Only occasional finds, shell beads inland, stone tools on remote islands, charcoal preserved in caves, hint at the scale of coastal life. Another unresolved question concerns the pace of rising seas. Geological studies show that at the end of the Ice Age, meltwater pulses could raise ocean levels by meters within a century. For communities living on coasts, such events would have been catastrophic. Camps and hunting grounds would vanish within a lifetime. Families would be forced inland, abandoning sites that had sustained generations. Oral traditions from indigenous peoples sometimes speak of floods and drowned lands, suggesting that memory of these changes persisted across millennia. Yet even as seas erased old lands, humans endured. They adapted to new coastlines, shifted to rivers and lagoons, and rebuilt their lifeways. The ability to move, to adjust strategies, to carry fire and knowledge into new places, these traits ensured continuity. Populations remained small, but they survived, passing their traditions forward. The genetic evidence shows that lineages established in Sahel more than 50,000 years ago remain unbroken today. Despite the loss of landscapes, people endured. One lesser-known aspect of this endurance is the persistence of symbolic practices. Even as coasts shifted, humans continued to paint caves, carve ornaments, and bury their dead with care. These acts anchored identity amid changing geography. Rock art on Sulawesi, ochre fragments in Arnhem Land, and shell beads found far inland all speak to continuity of meaning. The seas may have erased camps, but they could not erase the cultural life carried in memory and tradition. On a broader planetary perspective, the story of vanished shores highlights the fragility of the archaeological record. What we see is only the fraction that survived. Entire chapters of human history are missing, drowned beneath the oceans. Yet the fragments that remain are enough to show the outlines of survival. Tools, shells, pigments, bones. From these, we can glimpse how humans lived at the edge of the sea, how they adapted to change, and how they endured when worlds disappeared. Archaeologists now turn to marine methods to recover these hidden stories. Sonar mapping reveals drowned river valleys, deltas, and plains beneath shallow seas. Occasionally, divers recover artifacts from submerged sites. Each discovery is a reminder of how much lies waiting. The drowned shelves of Sunda and Sahul may one day yield new evidence, reshaping our understanding of early migration. For now, the silence of vanished coasts is both a limit and an invitation. The ecological consequences of rising seas also reshaped human life. Mangrove forests expanded, changing habitats for fish and birds. Coral reefs spread into drowned valleys, altering marine resources. Humans adapted by shifting diets, developing new fishing methods, and exploring inland environments. The loss of old coasts was not the end, but the beginning of new strategies. Each generation adjusted, carrying forward knowledge in different forms. The mystery of vanished shores therefore remains central to prehistory. How many camps lie beneath the Java Sea? How many hearths rest under the Timor Sea? How many ornaments and pigments are buried in drowned caves? These questions linger, unanswered but compelling. They remind us that human history is both known and hidden, preserved and erased. Standing today on a modern coast, one can imagine the ancient worlds just beyond the horizon, where waves break now, rivers once flowed, where seabirds wheel, families once gathered shellfish. The echoes of vanished shores remain in fragments of shell, in scattered bones, in the continuity of people who survived. They remind us that survival was never secure, but always possible through adaptation. In the end, the drowned coasts are both absence and presence. Absence, because they conceal much of our story. Presence, because their loss shaped the very people who endured. Humans learned to move, to adapt, to carry knowledge forward even when land itself disappeared. That resilience is the enduring legacy of vanished shores. It is why, despite all that was lost, humanity survived to inhabit every continent and ocean edge on Earth.